Hi, this is Francis from A+ Tutoring. In this session, I'm going to show you how to do this integral. This is from a past final exam, number 1B. Now from this integral, you can see that it's using integration by parts to solve, right? Because if you refer to the table that I gave you here in the summary, you know that e to the power of something, cos or sine of something, here is using integration by parts. Now, dv must be the e to the power and u to be the rest. Okay, so let's do that. So I have dv to be e to the minus 3x, and I have u equals to cos of 2x. Now what is v? V is basically minus 1/3 e to the minus 3x dx. Oh, there's no dx here. Dx supposed to be in the dv. So this is my v. Now what is my du? Du is basically minus sine of 2x times 2. So minus 2 sine of 2x dx. So I have something like this. Now if you have trouble doing this dv here, use a simple substitution for minus 3x. Then you can fairly see that the v is equal to minus 1/3 e to the minus 3x. Basically the trick here is to have the power here, the exponential, the coefficient of the power here will be inferred in the front as the coefficient. Okay, so minus 1/3. Now, if you have something like this, I need to use uv minus integral of v du. And then this is going to become cos 2x, right? And then phi is minus 1/3. So I have minus 1/3 e to the minus 3x cos of 2x minus integral of v. So I have minus 1/3 e to the minus 3x du to be minus 2 sine of 2x dx. Now let me rewrite this nicely. So I have minus 1/3 e to the minus 3x cos of 2x plus, well, plus and then minus again. So I have minus, I should have put a bracket here so that I know that it's multiply. So minus 2/3 integral of e to the minus 3x sine of 2x dx. Now, if you are scared to forget about the plus c, you can add it here so that you don't forget about it at the end. Now, following this, I see this integral again is integration by parts, right? It's exactly the same as my question, except that it's sine. So let's do this again. Let me recopy that. So I have equals to minus 1/3 e to the minus 3x cos of 2x minus 2/3 integral of e to the minus 3x sine of 2x dx. Now again, dv is basically e to the minus 3x. v is equal to minus 1/3 e to the minus 3x. Now this is dx here. My u to be sine of 2x. du is equal to 2 cos of 2x dx. Replacing this into this integral, so rewriting the whole thing here, I have something like this. So minus 2/3, right? So this is going to be open bracket, replacing this integral with uv minus v du. Right? So I have u, which is sine of 2x, v to be minus 1/3 e to the minus 3x sine of 2x. Subtracting the integral of v, which is minus 1/3 e to the minus 3x du, which is 2 cos of 2x, and then dx plus c, right? So I'm a little bit squished here. So let me rewrite all this in my next page. Okay, so I want to simplify this. Minus minus becomes a plus. I want to multiply this minus 2/3 as well. Okay, so my question here is basically integral e to the minus 3x cos of 2x dx. This is equals to minus 1/3 e to the minus 3x cos of 2x, right? Now I have minus 2/3 times 1/3 minus 1/3, so it becomes 2/9. Okay, so I have plus 2/9 e to the minus 3x. That should be sine of 2x. Okay, so sine of 2x. And then I have my integral here. Minus minus, but then I still have a minus. So I have minus 2/3, which is 4/9. Minus 4/9. So I have minus 4/9 integral of e to the minus 3x cos of 2x dx plus c. Let me double check that. So I have something like here. Okay, so that's good enough. Now I know that this integral is the same thing as my question here, right? So I need to group them. I'll need to put this term to the left side. It becomes a plus 4/9. Plus 4/9, it becomes 13/9 because this is a 1 here. 1 plus 4/9, which is 13/9. So I have 13/9 integral of e to the minus 3x cos of 2x dx equals to, now what happened here is just stay there, minus 1/3 e to the minus 3x cos of 2x plus 2/9 e to the minus 3x sine of 2x plus c. Now all you need to do is multiply with 9 divided by 13. Okay, so I can do that, right? So I know that my integral e to the minus 3x cos of 2x dx equals to, now 13 is at the bottom, 9/1/3 here will become 3. So minus 3/13 e to the minus 3x cos of 2x. Now the 9 cancel, all I have left is 2/13 plus 2/13 e to the minus 3x sine of 2x plus c. Now this is basically my answer for this question. Now you can basically factor out the common factor if you want, but it's not necessary. For more information about past final exam, please visit my website goforaplus.com.